Good afternoon, everyone. Welcome to Tufts School of Engineering Colloquium Series on Diversity, Equity, Inclusion, and Justice in STEM. Thank you so much for joining us today. My name is Chris Swan, and I'm a Dean of Undergraduate Education for the School of Engineering and an Associate Professor in the Civil and Environmental Engineering Department and in Tisch College for Civic Life. I will be your host today, and we ask that you silence your phones. Okay. And please do not use flash if you're going to be taking photos. Okay. In addition, this event will be recorded and will be posted at a later date. So you can tell all your friends if they're missing it, they're missing a fantastic event, watch it online. Okay. But we have a lot that we're going to be doing today, so let's go ahead and get started. I would like to introduce the Dean of Tufts School of Engineering, Kongbang Lee.
Good afternoon, and welcome to the DEIJ colloquium, the School of Engineering. I'm Kyung Lee, Carroll Family Professor in Chemical and Biological Engineering, and Dean of School of Engineering. I'm really delighted for this afternoon's event. We have actually multiple presidents in the room. How often does that happen? Today we continue the school's effort with a lecture by a national leader who's been at the forefront of efforts to improve diversity in STEM throughout his career. The US Bureau of Labor Statistics predicts that STEM jobs will grow twice as fast as other occupations by 2029, but research continues to show that high school students have declining interest in STEM fields. Our speaker's work he'll share with us today seeks to bring engineering principles, skills, and design experiences into high school curriculum to encourage more of our students to think about STEM as a path that's fulfilling and joyful. So as an Oakland, California native, our speaker grew up in a blue-collar family with an identical twin brother and an older sister. His parents didn't have a four-year degree, but they instilled him in a belief and a passion and a power of education. Before I say anything more and steal our president's thunder, I'd like to introduce Anthony Monaco, president of Tufts University, to say a few more words. Thank you, Tom.
Thank you, Dean Lee. Good afternoon, everyone, and welcome. I'm very, very excited to welcome our guest speaker, the University of Maryland, President Darryll J. Pines. In addition to his role as president, he also is the Glenn L. Martin Professor of Aerospace Engineering. And he's really been at the University of Maryland for much of his academic life, close to 30 years, where he also holds the Nariman Farvardin Professor of Engineering and was the Dean of the James Clark School of Engineering. But what he really has accomplished besides his own academic work is leadership and accomplishments, which have really changed the university and its stature, both nationally and internationally. Throughout his career, he's made sweeping changes to improve the student experience, including revamping teaching in fundamental undergraduate courses, emphasizing sustainability and service learning, and expanding innovation and entrepreneurial activities. Dr. Pines has also made prioritizing diversity a hallmark of his career. Under his leadership as a co-principal investigator, the university became a National Science Foundation Advanced Grant recipient to further develop a culture of inclusive excellence focused on improving work environments, retention, and advancement of tenure and tenure-track women faculty in ways that improve the culture for all faculty. Dr. Pines has led efforts to address the grand challenges of our time. Under his watch, 50 University of Maryland projects received a total of $30 million in university-sponsored grants to study and implement solutions in areas such as sustainability, literacy, and food, energy, and water insecurity. He also co-founded the 120 Initiative, an effort to reduce gun violence in collaboration with the consortium of universities in the Washington metropolitan area. Dr. Pines has testified before Congress about the importance of K-12 STEM education for all students and led an initiative to pilot a first of its kind nationwide pre-college course on engineering principles and design. The program Engineering for Us All, E for USA, has made possible through a multi-million-dollar NSF grant. In recognition of his work in both his field and his university leader, he was received many awards and appointments, including be elected in 2019 to the National Academy of Engineering. So it's an honor to have him with us today to speak. And let's give a big jumbo welcome to President Pines. Thank you.
Well, good afternoon, everyone, and thank you for welcoming me to Tufts University. This is only my second time ever being here, even though I was right down the street for like 6 years at MIT as a graduate student, and I lived in Somerville. It's a great place. So it's an honor to talk to you about engineering education and engineering. So I just want to do by show of hands, how many of you in the room have had an engineering class in high school? Exactly. That's what I thought I would see. Very few hands. There's not a teacher affinity group, believe it or not, for the field of engineering in high school, yet it's in almost every American college and university in the United States. But in our K-12 system, we don't have it universally across the United States, which is what I discovered years ago in the American Society of Engineering Education as part of the Engineering Dean's Council and as part of the K-12 Engineering Education Subcommittee, which I think Dr. Barbino was also a member of course. So I'm here to talk to you about an effort that's been going on for many years, which is to literally be able to teach any high school student engineering, to be able to train any teacher, whether he, she, or whoever they are, does not have a background in engineering, they're a history teacher, an English teacher, they can teach engineering through our training. So that's what I'm going to talk to you about. Here's my agenda. So first, to talk about why it's a national problem. It's very much akin to what Dean Lee spoke about. Program overview, I'll talk about how we do it, partnerships, curriculum, professional teaching and learning, some research involved, and then how we are trying to also, with our peers, get credit and placement, and then share with some student outcome, and hopefully at the end, if the Wi-Fi works, show a little student video. So this is the problem in the United States. Our students, our 8th grade students, our 15-year-old students are testing low on this international testing metric, which is called the PISA testing. It tests for reading literacy, mathematics, and science. And the US ranks 18th in science, 37th in math, and 13th in reading. And that was in 2018, the last time the test was administered because of COVID. It's usually actually administered like every 2 or 3 years. COVID caused a delay. It was just administered 2022, but we don't have the results. In addition, in 2018, 61% of high school graduates did not meet ACT's College Readiness Index. So these are the ones that would go into STEM, but they're not really getting there. So this is a problem. And why is it a problem? Because of the low birth, so focus on the left chart for just a second with me. It has sort of 2 figures on there. It has a bar chart and it has a curve. The curve is actually the number of high school students. The blue curve is the number of high school students that graduate every year, roughly about 3 million. What do you notice on the far right of that blue curve? It's going down. You know why? Because the US birth rate is going down. So it's projected based on going back 18 years that the birth rate's going down. So by 2028, this number is going to come down below 3 million. It might be somewhere around 2.9, 2 point something million, but even continue to go down as we go into 2030. That's not good for us because throughout a long time period, the number of available high school students who graduate from high school, only about 3 to 4% enter as freshmen to Tufts University or any university in the United States. That number hasn't changed for a long period of time, right? So it's the same percentage, roughly about 4%. It's still projected to be 4% going forward. So if the blue number goes down, then we're going to have less students available entering engineering. That's the problem. That's the national problem. The bar chart is on the right. If you look at the right axis of this left figure, it's the number of students that actually freshmen that enter engineering every year in the United States. So say 120,000, right? So again, if the blue curve goes down and that percentage stays the same, then that's only 4% of a lower number. Are you with me? I know you tough people can do math, so I know it's really straightforward, right? Right, Dean Lee? So, so there's two problems here. So can we develop a high school course that reverse these two trends? First, the number of available high school students that go into STEM generally, and can we increase that percentage over time? Right, that's really kind of what we're trying to do, sorry. Okay, now, if you follow the national academies in the United States, especially the National Academy of Engineering, National Academy of Sciences, they've been talking about this for more than 2 decades, that this is a rising storm. And we in the United States need to do something about it. So it started way back in 2006 with a report that had these people on there: Norm Augustine, the former president of Lockheed Martin; Dan Moat, the former president of the National Academy of Engineering and my institution, University of Maryland; Dr. Linda Katehi, who was the president at UC Davis. They wrote the original Rising Above the Gathering Storm. And since then, there's been many reports about how we could change engineering education and incorporate it into the K-12 system. That led to the Next Generation National Science Standards, which now for the first time in 2012, 2013, actually included a framework for teaching in engineering education in K-12, which allowed us the opportunity under NSF funding to now advance a high school course, which we have called Engineering for Us All, as an entry gateway into the field of engineering, right? So that's how it all started. Okay, so now I'm going to talk to you how it all works. So what are we trying to do? We have developed a curriculum. We have developed a methodology for how to do professional learning and teaching. We've established partnerships with high schools and universities. We've actually even developed an assessment, but we don't talk about that much because we need a lot more data to make sure that we're seeing what we're supposed to be seeing. We have an external evaluation of our program, and we have worked with partner universities to grant credit and placement for the high school course. So you get dual enrollment credit, and you get hopefully at some universities credit and placement, credit and or placement. And we have a research component, as you would expect for an NSF grant. What's the framework for how we're doing this? So here's the hypothesis, the theory of action. Democratizing of engineering education for all can be achieved by bringing together stakeholders to engage in pre-college students in the scaffolded disciplinary practices and evaluation of the real world consequences of engineering. So what happens to all of us, even when I was going through engineering, you learn the math first, but never in context. Well, why am I learning all this calculus stuff? Why am I learning differential calculus? Why am I learning anything? Because it wasn't connected to actual real world engineering, right? But we've connected it to it, and we've done it at the algebraic level. We have a curriculum, age appropriate, team-based, progressively challenging projects as you go forward in the curriculum. We have a tool, and this is primarily for teachers. It's registered and trademark product that we developed. It's an online portfolio that allows you to do the design process online. So as we know in engineering, there's a problem statement, set of requirements, conceptual idea about the solution, some analysis, results, and a feedback loop to iterate. I simplified it, but you know what I mean. That's all embedded in the Mind Design software. You get the software when you become a part of our program and you're a teacher, and you can use it to grade student designs. We do the teacher professional development and learning that we do multiple times over the year. And then we've created this teacher community of practice that allows for feedback and for new and innovations to happen among teachers talking to one another. So that's the way we do it. And the outcomes are students learn about the field of engineering, teachers have confidence and have the requisite skills to teach engineering, even if they've never had engineering in their life. We can actually teach those teachers. Okay, how do we do it? So we decided that, we're going to make a 30-week course over an entire year for high school students. But what we want them to first do is for themselves to discover their identity connected to engineering. So what I always like to say is, like, if I'm out in Copley Square, standing at the middle of the street corner, and I just stand there, and if all of you are engineering people in the room, all around you is engineering. Just stand there. You see buildings, you see electrical lights, you see cars moving, you see mechanical systems. All in front of you, if you never think about it this way, is engineering. It's slapping you in the face. So what we try to do with our students is we tell them to go out in the environment and discover engineering on your own. What you think you identify, and then identify what you think is engineering. The idea is, our goal is truly for any high school student, whether they're going into STEM or not, they can learn engineering. So the goal that Dr. Don Millard, who's at NSF, our program manager initially, he believes that our goal is to democratize engineering for everyone, to make engineering a core subject in high school, like English, like history, like mathematics. Why not? Why not? It can be done. And my goal is make sure that every high school student should learn the principles of engineering, period. So we've divided into 4 core subject areas: discovering engineering, engineering in the context of society, that is, what problems do engineers solve, engineering professional skills, what skills should we develop as an engineer, and of course, the coveted engineering design process, which all of you know about. You've heard about the scientific method, correct? Engineering design process is the other part that no one talks about in high school. Okay, here's my team. We've now been doing this for about 5 or 6 years. Each of these individuals are incredible. They've done some incredible work. Some of you know Dr. Stacy Klein Gardner, who's been my partner in crime for now 6 years, and she's the co-director of the program. Ken Reed, who used to be at Virginia Tech, is now at the University of Indianapolis, was the curriculum lead in engineering education, helped led the team for curriculum development. Brooke Burhani, who's now at Florida International, used to be at Maryland with me. He's our partnership lead. Jenny Kuhl is our leader in teacher professional learning and professional development. Adam Carberry, who is at Arizona State, just became the chair of engineering education at Ohio State, has been leading our research activities, and then our credit and placement activities have been led by a gentleman by the name of Kevin Calabro. We have a team of evaluators called STEM Education Insights, and they've been extremely helpful. And then we produced this little app we call My Design that fits on any mobile or your computing device to evaluate designs. Okay, so what is unique about E4USA? This course promotes the development of students' professional skills through engineering design experiences. It is not a technology-focused course. It is not a survey course. It's about these specialized design experiences. The course is designed for all students in mind, inclusive of both students who plan to pursue engineering and those who do not plan to pursue engineering. Intended to provide connections for students among fields of personal interest. High school algebra is the only prerequisite for the course. And you know why we did that? We didn't want to lose anybody from a diversity perspective. The moment I put pre-calculus, I lose a lot of people. The moment I put calculus, I lose a lot of people. I don't need to teach engineering with calculus or pre-calculus. I can teach it with algebra. And then more people understand what engineering is. So it started in this workshop in 2018. We had a workshop. We were initially going to, and you might remember this, Dr. Barabino, we were going to try to remember an AP. We were trying to do an AP in engineering. We were working with the College Board, but we had this workshop sponsored by NSF, and everybody said, don't do that. Do a course for everyone. Pull out the calculus, pull out the pre-calculus, do algebra, do a design-based experience, and that's what we did. So, and that was the right move at the time, and it's been the right move since we've moved forward. All right, so there's a core team, different universities, NSF's funding. Now let's talk about how we do it, partnerships. So we have partnerships between high schools, individual teachers, the students that they're teaching, and academic institutions like mine. So we try to do this regionally. So in the state of Maryland, there'll be a host university. It'll have partner high schools. It's easier to do that way because you have relationships with those high schools. And therefore, those students are already coming to Tufts University or already come to the University of Maryland, so you have relationships which are really nice to have to work with those people you already know. So this is kind of how we are in a given year. Somehow, I think you got the wrong version because there was a chart before this. We started in 2019. That's my fault, not your fault. We started in 2019 and we had only 9 high schools and 9 teachers, and we were only in 5 states in the District of Columbia. This is the second year in which we went from 9 high schools to 36 high schools, 39 instructors, 12 states in the District of Columbia. And we're only doing like 1 or 2 high schools in each state. And those are the logos of the high schools that we've been working in. And then we go to the next year, and now we're up to 47 high schools. And now what we started doing is we created 13 new high school partnerships that also involved FIRST robotics. So we do our core curriculum, but instead of doing design problems that we do with the community, we do design problems that are focused on FIRST robotics. And that was through another grant from NSF. And so we wanted to do that. And then let's just dig down in terms of this particular year. So we dig down, and this year, 47 high schools, 49 instructors. We had about 47 schools, 49 instructors, but 1,426 students took the course somewhere in those 19 states in the District of Columbia and the US Virgin Islands, right? So that's been really great. And some of those schools, believe it or not, that we partnered with were what are called junior ROTC schools. We didn't know that at the time, but they're junior ROTC schools. And so they have other students that are doing junior ROTC program kind of work, leadership program. So that was actually good for many of the schools that we had in our program across Virginia, Tennessee, and Maryland and Massachusetts. There was one up here in Massachusetts, in Revere High School. So now what's the demographics? So it turns out, as I told you, this high school course can be taught at any time. You can take it as a freshman, depending on whether you have the algebra requirements. You can take it as a sophomore, same algebra requirements. So this has been the spectrum of this particular given year. So we had 296 freshmen, 613 sophomores, and as you can see, roughly about the same number of juniors and seniors. So it can be taken at any grade level. You just have to have the algebra requirement. That's it. What's the diversity of these students? 48% were white, 26 for this particular year, 26% were Black, Asian 17%, small obviously on American Indian Alaska 1.3%. And then when you break out from Caucasian into Hispanic and Latinx, if you break it out, it'll be another 20% that were from Hispanic Latinx backgrounds. So pretty diverse. Now, what's the given year that we're in now? This is where we are today. We got 63 teachers. We're in 16 states in the District of Columbia, US Virgin Islands. Still have the 13 E4USA FIRST teachers. But we pretty much have touched, a good portion of the United States and the 2 coasts, which we're really excited to be in. Also, all the big states of the United States. And that's a summary of everything that I just showed you before of the 4 years that we've been teaching this course. Now, cumulatively, we have touched 92 teachers, 21 states total, because some states are not active every year, DC and the District of Columbia. So we really have almost, we touched the states that we actually wanted to be in. We didn't go everywhere because you can't be everywhere. But the university that want to be partners with us, the head of high schools that want to be partners, we found those partners, and that was really nice. Okay, that's the same summary. So 82 schools, 92 teachers, 5,000 students served, actually it's over 6,000 now. And there are 18 institutions that give credit and placement in the United States that are universities. By the way, Tufts is not one of them, Dean Lee. Just saying, I don't know what's going on over here. I'm gonna skip these charts. So let me talk about the curriculum. So this probably took the longest to do. It really required lots of vetting. We've got lots of really smart people who are from engineering education community. So our goal was to do these 4 sort of domains: discovering engineering, so connect with engineering, engineering professional skills, engineering in its context of society. What does it, what do engineering solutions do for society? And then of course, really drill in the engineering design process to our students and to our teachers. 30-week course. It's broken out in 8 units. So unit 1 is engineering is everywhere. As I told you, stand anywhere at Copley Square, engineering is everywhere. Engineering is creative. This is what a lot of people, this is what gets everyone. We don't do this enough. Our field is creative. It's not just that we solve these problems, it's creative. So if Gilda finds a solution to a problem, my solution might be different, but it solves the same problem. And we never talk about the creative part of our field. And that's what actually gets students really excited about, because it's creative, it looks different. I made a different shoe than you did. It does the same thing, but it looks different, right? It's creative. Engineering is human-centered. It's focused on the human. We wanted to really have that as a human-centered component. Engineering is responsive. These are actual units that we teach. Engineering is intentional. Engineering is iterative. You all know that, okay? You all know that. And then we have a little bit of personal reflection that goes on in our course. Engineering is personal. What do you really want to get done as an engineer? We have students talk about that. And then we have them reflect on their own designs, right? It's reflective. You kind of think about it. Did it really cover everything I wanted to cover? So it's been really exciting. I want to show you a few sample projects that our students have worked on. So I'm going to walk through a few cases so you kind of see what kind of work gets done. So what we try to do when we're teaching this course is we try to have a community partner. So we don't just do it in a vacuum. And this is another thing that tends to bring in creativity, but also makes students understand that there's a social connectivity to the fabric of why they are going to be an engineer. They could help another human being. So in this case, the community partner was the Image Center of Maryland, helping disabled community live in their community. So the need was a child had disabilities and that child could not enjoy himself on a normal swing. So they needed a portable swing to provide safe play to make sure that that child was safe, but it could enjoy a swing set like any other child. So the students did this. Students designed an assisted swing with an innovative harness for a needs member in the community. And it made them feel really good because that child was really happy, right? And that's the image of the actual child. That's the image of the actual system they developed. And then that was deployed into an actual playground that was near that child's school, right? Real solutions for real people using engineering designed by students, not by faculty, by students, high school students. Similar kind of project. Community partner, this was at Vanderbilt. This was under Stacy's leadership. So VU Center for Autism and Innovation co-director was a partner. Need was an ability to work a retail job using both hands, right, for an autistic student. So there's an example of the harness that was developed with a needs-based dog that allowed the limbs to be free and to move around with the dog. Designed by these high school students that you see there from a high school called Brentwood in Vanderbilt area. So again, a new hands-free leash for an autistic young woman's service animal. So this is what gets students excited because they're actually doing something, again, to help a real person. Now, here's something that's really interesting. Very simple passive design. So how many of you have a cell phone? All of you do, just messing with you. I love that, you know, when you're a professor, right, Dean Lee, you can get people to do anything. I can get you all to stand up if I wanted to, I'm joking. So community partner, see, just messing with you. Community partner, seniors in the community, okay, who have unfortunately a hearing deficit. And so they watched these seniors in the seniors assisted living center, and they saw them having trouble. Some of them had hearing aids, some of them didn't. And they came up with a solution so they could hear their actual mobile device by an acoustic cavity. They designed the cavity, they tested the cavity, and all it does is it amplifies the acoustics coming out of their own phone, passively, right? And they put this into play, and the community was grateful for it. And all it required was first to do the acoustic analysis and develop 3D printed amplifiers from their 3D printers at their school. What a cool idea, right? All by the high school students. So This, when you make the problems socially relevant and you make them connected to a community partner, engineering is fun and creative. Professional learning. So this was our first cohort of teachers. Boy, they really trusted us. We were grateful that they were willing to work with us. This was in 2019, 2020, just before it was the summer of 2019, just before the pandemic unfortunately started. So it was mostly in Maryland, Virginia, Tennessee, Pennsylvania, and the District of Columbia, each one individual high schools. But these were the teachers, and some of them are still with us now 4 years later, like Jim Muscarella is still with us, Richard is still with us, Mike is still with us, and Brendan is still with us. They've now in their 4th year of teaching this course. The very first year we had 9 high schools, 427 students. We gave each teacher a stipend of $5,000 and $2,500 for materials. And we did that across the board in the United States. Everybody gets the same normalized amount of money. And then we had them come to the University of Maryland in the summer of 2019, and we used our own facilities to teach them engineering and train them in engineering. And just to go back a second, music teacher, the only engineer in the group was Sharon. History teacher, science teacher, math teacher. Jim was another math teacher. And David was a math teacher. So only one engineer in the whole group. By the way, the history teacher and the music teacher did the best in teaching. So we have 2 ways of doing this. We had a marathon version of how we teach the course and train the teachers. It's a 4-week professional learning experience, but we also can accelerate it into a daily experience that's over a week. We call it the sprint version versus the marathon version. And we continue to do this process with teachers today. This is all of them again in the shops learning. So it's really exciting for them. There's Stacy again and the entire team working with doing the professional learning. There's Adam Carberry, those of you know him from Arizona State. And then the pandemic hit, and then we had to really adapt. And this is actually really hard for us because the program almost collapsed over this nightmare of the COVID. But we were able to pivot and actually deliver all of the training virtually to even expanded high schools that we never even went to physically. It was all virtually done, but we were able to do it and keep the program going and meet new teachers, and they did really well, and they were really excited. They had a lot of fun doing the learning and doing the teaching. But the most important thing that we created was this community of practice. So we had teachers who had been in our program for a year or 2, became master teachers to new teachers. We would have community sessions for them that's above and beyond the training sessions by creating this little community of practice so that they could get new ideas from their fellow teachers to teach better in the classroom and to have new design projects. A lot of partnerships, university partnerships. We've got Exponent, we had MATLAB as MathWorks as a partner for the tools. And so it was really, really growing enterprise for this course. I'm gonna just skip that, but this is kind of how we do it. So essentially our PD throughout the year, we teach them how to use what we call the design rubric in our app, little app that we call My Design. We start doing the initial professional development into winter term. Then we do an end of year teacher celebration, and then we create a community of practice and teacher performance and reflection time periods at the end of the academic year. Here's a more detailed schedule. I don't even know why I put that chart in there. All right, we do a little bit of research, but I'm going to skip the research and so that we can move over, just so and for brevity, so we can just skip that. Those of you who want to learn about that, you can talk to me at the end. We can go through all of this, but I'm just going to skip over it for now. And just go to credit and placement. So we now have these schools granting credit and placement. So, and also we just got UMBC. So you see Purdue in there, Virginia Tech, of course, University of Maryland, where I'm from, George Mason, Florida International, Arizona State, Tennessee, University of Hawaii, University of Indianapolis, University of Louisville. We would love to give Tufts, but it's up to you guys, right? You don't want to be the last one to the party. Because when I have 50 up here, you're going to look pretty bad. They laughed at me when I had 2 up here. Now we have 18. Not that it's growing every day. So how can it be done? So it doesn't have to be in your core curriculum, right? It can be in general education to get credit. So we do the way people have been granting credit is either through concurrent enrollments. What that means is if you have a parallel course here at Tufts that is very similar to our content, then obviously you can grant credit for that. We have a learning assessment exam that we give to the students. So that could be used as a mechanism for credit and placement. And then there's a credit and placement exam that we also have. So there are multiple ways to do it. Each university does it a little bit differently to grant credit. And some people do it in core engineering, elective engineering, or general education. So Arizona State, we have a prospectus, Dean Lee, so I'll send this to you. It tells you how each school does credit and placement, just to give you ideas on how you might do it here at Tufts if you're interested. So I have this for everybody, so I'm just going to skip through them all. This is just my school. We actually do 2 things. We do a test, but we've also created in our general education requirement for all students, we created a class called E4 USA for non-engineering majors. And you know what? That class is full every semester with 100 students. So students want to learn about engineering. They actually really do want to learn about engineering. We also do an exam, and we do it in concert with our My Design rubric, so that students can submit a design and it can be measured and evaluated by our team. Again, this is done at some of the institutions as a way to get credit and placement. So that's a barcode that tells you where the prospectus is. You can take a picture of that. Now's the time to use your phones. Is that okay, Chris? No flash, please. Okay. Okay. All right, now here's the best part, student outcomes. So in the first year, we had these high schools participating, and these were the seniors that completed. You know, we had a lot of different freshmen, sophomores, and juniors, and a few seniors. So I'm just going to show you where some of the high school kids went. So this is Eleanor Roosevelt, a school in Maryland. It's a really good school. And we anonymize the students, but not their gender. So you can look at that spectrum of 13 students, just to let you know, just go back a bit. So 13 from Eleanor Roosevelt High School. Look where they went. University of Maryland, Purdue, University of Maryland, Messiah College, UMBC, University of Maryland. Of course, they're close to us, so they're going to come to Maryland. University of Pittsburgh, Air Force, and Widener University. Almost all of them in STEM, right? I'm not saying that our course made it happen, but I'm just saying, I mean, the evidence speaks for itself. Look at the engineering disciplines, right, that they went into in computer science. Okay, so that's that school. This is a totally different school, Plymouth White Marsh High School in Pennsylvania. Look at the engineering. Speaks for itself. Look at the schools. It's typical that you stay in your own home state where it's cheaper. In-state tuition, kind of natural, right? Public and private. Some went to Purdue, really great school, right? Evidence it's in the pudding, right? There it is. Now this is it's next to my institution, College Park Academy. It's a very diverse school. Most of the students are from diverse backgrounds, underrepresented, low socioeconomic background. But even these students went to all these community colleges. So went to, which are in Maryland, Anne Arundel Community College, Howard, Prince George's Community College. And now I've tracked them for a couple of years. So now many of them have now transitioned to STEM majors in universities. Again, really, really good sign. So now we asked for our teachers to give us a few student testimonies. E4 USA's biggest impact in preparing me for college engineering was project management. While the requirements, projects, and information are always changing, the process never does. Having spent a year learning how to efficiently and effectively work through an engineering project before I came to college, I was well ahead of the curve. This allowed me to spend time making sure that my work was the highest quality it could be, as well as make sure that everything got done on time. That's Jacob Davis, who went to Purdue, who was in Pennsylvania. Here's another couple of students. Learning how to code and 3D model in one of our E4USA projects has been very useful since our final project is a robotics project. My E4USA experiences have allowed me to be an effective leader of my project group as well, Tyler Bedford, Drexel University. And last one, E4USA and you prepared me for my first year of engineering school by giving me the experience and exposure to the engineering design process. And you can read the rest. So it's helping these students. It really is helping these students be successful, which is what we all want. Okay, now I want to play that video. Is that okay? We got Wi-Fi. Okay, I don't know how to work your screen. Is there a mouse? You have to come and do it for me.
If I can get it open.
You just click on that link.
Here?
Yeah, it should be able to click on it.
Did it? Did it? Did it start? No, it didn't. There it goes. There it goes. All right, ready?
Really know what to expect, but we simply learn about the world
You
and
start from
use
the
our own
beginning,
skills
from the
to
beginning.
build inventions that can actually make a
E4 USA.
E4U,
What is E4 USA?
E4USA,
E4 USA.
Well, E4USA is a class that shows us everyone, no matter their passion, can be an engineer. That's why they named it Engineering for Us All.
I'd never done engineering before, so I didn't really know what to expect, but we simply learn about the world and use our own skills to build inventions that can actually make a difference.
My team designed a crosswalk simulation so that students with learning disabilities could learn how to safely cross the street.
we built a water filtration system to collect water that is drinkable on the reservation.
The Nashville Zoo asked us to create a feeder device that'll enable the caracals to imitate what they would be doing out in the wild.
My class is building different solar-powered musical instruments that we can actually play.
It's so good. Sure, we could get college credit by doing this program, but it's more than just that.
In E4USA, we learn to think deeply and critically,
To collaborate with each other and to let our imaginations run wild.
This class showed me that I can make even the biggest of impacts in my community.
We learn how to grow as both engineers and people through both our failures and successes.
We call it the Hand Sanitizer Nader 3001.
We are the Service Dog Harness Group.
This is a device we made for feeding giraffes.
If your school already offers E4USA, then sign up. If not, you can get your school involved by going to the E4USA website right here.
Okay. Questions? Thank you. Doctor.
I'm first going to say hello. I don't know if you remember me. I'm David Hammer. I was at Maryland for.
Yes, I do remember you, David.
I see this great stuff.
Thank you.
So my question is actually comes from one of our colleagues, Maryland Dan Chazen.
Yes.
I think, well, he taught me to wonder, should everybody take algebra? So my question for you is, do you actually have evidence of a need for algebra in the program? Why require algebra?
Well, you mean for this program?
Yes.
No, do you need algebra? No.
Not in, I mean, for your program, you say the minimum requirement is to
Yes.
have algebra.
Right.
And I'm wondering, do they really need algebra?
They don't, but I have to start somewhere, David, right? Because I want to get them on a trajectory so that I know they will get into Tufts engineering, which I know it's going to require pre-calculus and calculus. So I have to start somewhere. And that is the only reason why we put it in there, right? That's number one. Number two, we put in algebra because we didn't want to lose diverse groups because they thought, oh, it's too hard because it requires calculus. Engineering design process is not too hard. And once they see the creative part, then it accelerates them to choose more math because now they want to get on that trajectory for STEM, right? So we have to start somewhere. We decided to start with algebra. Everyone agreed in our little workshop that we had in 2018 that was where to start. Valencia. Yeah.
Thank you, President Pines. Very inspiring program. And it would be great to hear your thoughts on what are some of the challenges or hurdles in scaling such a program?
Oh, great question. So NSF, as you guys know, so what happened was we got the first 3 years of funding, and we were just telling NSF we can only do so much with this amount of funding. And then we got the second 3-year increment, and they said that's it. And so so we're in year 5 right now, and they want us to become a 501c3 and scale. Now that's just acting like any other foundation, 501c3. I've got to go out and fundraise and get money. So we just heard yesterday, what is today? Friday? Yeah, yesterday, because it's easy for me to work in the state of Maryland. So I went to the state legislature and I said, look, let me scale this program, which I've already now done in 18 high schools in the state of Maryland, to all 282 high schools in the state of Maryland. And now they just gave me the first tranche of funding. Like literally it's going to show up on July 1, which will go directly to the 501c3. And then we'll do about something like 50 high schools per year for the next 5 years. So that's to get the scaling that you're talking about just for the state of Maryland. And then now we're talking to foundations, around the country to go and do it in different places. But we'll take this model from that we'll do with the state of Maryland, so we can do it in Virginia as well, since it's so close. So yes, it's hard to scale, but we're ready to do it because the success is there. And the other thing I would show you is, I think it's probably not in this chart. Yeah. So I just came back for our first foray internationally. So last week was our spring break, and I was in Ghana and Nigeria, and I met with the Minister of Education for Ghana, and I showed him this course, and we signed an MOU that he's going to put it in 12 high schools starting this fall. So we're going to help train the teachers this summer. We'll do it in country, so we'll come back in the summer because they're trying to, again, grow their STEM capacity as well. So, yeah.
Have you thought about trying to put this outside of high schools and into like libraries and other areas where maybe a high school might be resistant to the program, but a local library where high school students can go and hang out? And
well, it's not an after school program. It is a dedicated curriculum, right? So could we do the design projects outside of that? Sure, we could. But we actually want students to get credit for high school and potentially credit for college, right? Because we want to get them on a trajectory. So we don't see it as an after school or summer kind of program. We see it as actually an absolutely embedded curriculum. So even in the state of Maryland, the reason why we were able to get the money from the state is that I went to the superintendent and I got it approved as a career technical elective. So now engineering, computer science are both CTE. So now students can take it and get high school credit, and as well as potentially get college credit. So. Yes, so we have 2 community colleges involved on that. My 18 schools, one of the schools is a community college in Arizona, and they accept credit and placement as well. Absolutely. So we kind of, because we're from higher education, we're from 4 years, so we kind of focus on 4 years, but we see a lot of interest in community colleges. So, Meredith.
Thanks so much for the presentation. There's so much work happening and thinking about, the ways that we design curriculum and pedagogy to support a diversity of learners. I would love to hear more about how you guys, what were the curriculum design principles?
Yeah.
Or the ways you work with teachers to support and draw on some of that work.
So, there's a lot of research that we're doing that Dr. Klein Gardner, who you know personally, as well as Dr. Carberry, they've been doing that engineering education teacher efficacy sort of understanding of pedagogy. And they have just published a couple of papers that just came out in the Journal of Engineering Education. There'll be like 4 or 5 papers at the American Society of Engineering Education Conference that will talk about we finally got these results only recently. Because you don't want to come out too early. We've been doing this now for 4 or 5 years, but we only had survey data for the last 3 years for our teachers. So now we think we have data that suggests that the pedagogy and the way we've been doing professional learning and professional development is actually making the teachers better teachers in the classroom and reaching the outcomes that we care about.
Cool. I guess my question was a little bit before that.
Okay.
What was the research or theories you drew on as you were designing this?
And I should have you talk then to Ken Reed. because he has theories that he's following. Absolutely. Yeah. So I'll put you in touch. Yes, Dr. Perez.
Yeah, hi.
See how many people I know at the Tufts already? Just in this little short trip I made. I'm just gonna say.
Thank you so much for your presentation
You're welcome.
and for sharing with us the project. I'm curious, and this is more along the lines of the prior question. When you look at the pool, at the rationale for the project and the pool of high school students and how is projected to be in decline, do you consider this data disaggregated by different racial,
Yes.
linguistic groups that may have demographic trends that speak for an increase of these particular populations in the high school population, and how these programs like this could support that growing population of students? So that's one of the, and please feel free to just answer one because I have a gazillion number of questions. But the other one is around the framework for engineering embedded in the next generation science standards, and how it portrayed a particular perspective of what engineering is. That is based on consensus and not necessarily research evidence-based. And how may have you incorporated or like pondered this situation that, you know, this is great a start, but this is not what all of what engineers do necessarily.
Yep. Okay, so two questions. The first question, we were purposeful and intentional in partnering with high schools in 3 domains: urban, suburban, rural. It's number one. So geography was important, zip code was important to us. Then the demographics of those schools. So we have a couple of high schools that are predominantly African-American. We have a couple of high schools that are predominantly Hispanic and Latinx. We have a couple of high schools that are all women. 2 high schools of our program are all women, purposefully done to show that all demographic groups can learn this class and do well. That was really part of what we were doing. And number 2, to make sure it was very inclusive for all population groups so that we could have everyone learning this course, of whether you were in rural states or rural counties or urban cities like Baltimore. We had 2 or 3 high schools in Baltimore, 1 in the District of Columbia, and other cities as well. So that was purposeful. So that's why our demographics are so good, right? 40% women have taken this course, or girls have taken this course, and very diverse, as you can see. That's number 1. And by the way, the other thing that we had was socioeconomic, based on zip code. We figured out high-end folks could learn this course, as well as folks who have not as much means, right? Your second question, we had to follow the next generation science framework because, let me tell you why we did it. And then we added stuff to it. But we followed it because the states had to follow it. So if we wanted to get this course to be accepted at a high school, we had to have something that was foundational that we could speak to. So it was the next generation science standards. Secondly, we had to fall into their models. Every state in the United States is so different. It's unbelievable today, even my state of Maryland. So we had to figure out what would they accept? How could we get it in there so they get dual enrollment credit? So we found the CTE was our mechanism for Maryland. But in another state like Arizona, it's different. And it's in a different mechanism. So we had to follow the framework so that they would say, oh, it's foundational, it's following next generation science standards. So we are doing that as well as a K-12 system so that they would even talk to us, right? And then find a way to get into their systems. And we did that school by school, not by, I would say it wasn't by superintendent or by the entire county, it was just by school. So
thank you.
You're welcome. Erica, see? These are all the people at my table.
So when I was in high school, my school had a course on C++. And I remember looking at that and thinking, wow, that looks interesting, but I think I'm too dumb for it. So presumably this is an elective class that high schoolers choose to sign up for. And I was wondering, what do you do to make it look non-threatening? So people think this looks like something I could do, even if they're not someone who they think could be an engineer.
Yeah, I think the first step there though was, it's not just the students, the teachers were feeling the same way. right? Like literally imposter syndrome. And so we had to say to history teachers, English teachers, when we were meeting with them, look, we're going to help you learn this, and you're going to be excited about it, and you're going to build something, right? And they were like, oh, I don't know, we don't have a STEM background. I said, don't worry, we're going to give you as much as to be dangerous. And so we had to overcome that part first. And then once we did that the first time, because it was really hard to do it the first time, and we had these teachers, these 9 teachers, then they could tell other teachers, like, look what I did, you know, and then they would go and share that with students. So actually overcoming that was through the teachers. And then they would engage the students and say, you can do it too. Look, I did it. I learned how to do this because I'm going to be teaching it with you, right? So that was our way of getting to the students, because we really mostly got to the teachers. And they were so excited to be able to learn something new. And they also got credit for it, the teachers. What do you call them? Career educational credits. They got credit for it in the state of Maryland, the state of Virginia, state of Arizona. And we work with the states to be able to do that. So, but they were our avenue to helping students get over the fact that they could learn the subject. So, yes, Gilda.
So, Darryll, I was with you when you started engineering for us all. So I remember the difficulties, and I want to say congratulations on this huge success.
Thank you. Appreciate it.
So my question is, we all know that math is a huge gatekeeper to engineering. So in this program, you just showed that students, high school students, could master engineering skills regardless of math.
Correct.
Or what level they had. Is any of that transferable, like proof of principle, that we could apply at the college level to say, you know what, we've been using math as such a gatekeeper. Does it really have to be that gatekeeper?
That's a really good question. Yeah, it's a really good question. I actually never thought about that. Of course you're right. Of course you're right. If it's working for these, students, it'll work for college students. But the problem I think that we all have in engineering, it's been the same way for hundreds of years, right? And all of us will say, well, that's how I came up. So that's how Gilda, you're going to come up. That's how your son's going to come up. That's how everyone's going to come up. But that's not right, right? And so we could break away from that framework with this little one course sequence and show people that you don't need the math. The social context to a problem was more important to draw the student in, and then showing them the process that it's creative and you can actually come up with solutions, you can build it with your own hands. We've proven that. It's a proof of concept. We've done it so many times. We've proven it, right? So you're absolutely right. You don't need to have that same structure. You can do it totally differently. But the question is whether colleges of engineering are willing to do it, right? I think we need to push them. I totally agree. Totally agree.
Time for one more question.
In follow up to that, I mean, at the end for the engineering colleges and universities, it seems that having those foundational pre-calculus physics requirements are part of our accreditation as well.
It is.
Their engineering programs.
Correct.
So we do have to get them to that level. So how do you bridge them from the
But remember, we own the accreditation. We, you, me, engineering, we set that up. We can change it. It's going to take some work, some heavy lifting, but we can change it, right? I've been on the accreditation boards. I've been to review teams all the time, right? And we had these arguments. Remember, we had these arguments about certain things to include that the accreditation boards didn't want to do it. We didn't have enough votes, right? Because again, it's historical, it's cultural, it's been there all that way, all that time. So they only tweak around the edges rather than having a holistic look at it. We actually need a holistic look at it because we're showing that we can make it work, right? In this one course, we're about to do a second and third course right now too. We're looking at another course. So the bottom line is you're absolutely right. It has to go through those bodies because this is the struggle we have with College of Engineering accepting credit and placement, is because everybody says the following to me. I've been a dean for 11 years, so I've heard it all. So this is how we do it at Tufts. Okay, this is how we do it at Maryland. This is how we do it at MIT. Don't give me that nonsense. Engineering is engineering. I understand, you know what I mean. You bring your students in, you indoctrinate them into the Tufts culture. I got it. Don't think I don't understand what you're talking about. And it's about, bringing people along the way you like to do it. And so this is their resistance to any change. And we're all this way. At Maryland, it took me a long time. I was dean for 11 years. It took me to the 9th year to get my colleagues to accept my class, right? and finally got him to do it. But the bottom line is, it's just because we've been doing it the same way, and it's the way we do things at this institution, the way we do it at that institution, right? And so it's just hard to change. So that's why I only have 18 schools. I should have by now 100 schools, right? But that's just the way it is. That's how my colleagues are. That's how we are all. But right now, University of Oklahoma has taken this course, and it's their entire first year course now. So I'm really excited about that. They're doing it this fall. It's be their entire first year course. So we're making progress slowly but surely.
So how are you bridging them into the higher level math? I mean, is that? not-
Oh, so basically what's happening, when they get excited about doing engineering, even at this level, they want to take the next level of math because they want to go in the next level of engineering. So that's what we're seeing with these students, and they end up going into engineering in college. So we're about to have our first graduates from the Pennsylvania high school. They'll graduate from those Purdue's and Temples and Drexels of the world, because it's now about 4 years we've been doing this. So we'll see our first graduates from E4USA out of colleges. So, all right. Well, thank you, Dr. Swan. Appreciate it.
Yeah. I want to thank you again for doing this, and I want to bring up Dean Lee to finish up our ceremonies.
Grab something real quick. Okay, thank you. So President Pines, it was amazing. And thank you so much for the inspiring talk and presentation. It's a small token of appreciation on behalf of the School of Engineering.
Thank you.
Something to remember by.
My pleasure. Thank you so much.
The only one request I have is that you're not
Yes.
allowed to donate this.
No, won't donate it. Is it some tough swag?
It is some tough swag, yeah.
Let's see what it is.
You'll notice an
Oh, look
elephant
at that.
and yes,
I'm gonna have to open so people can see. Is that okay?
absolutely.
Oh, this is beautiful. Look at that. Is it nice? All right. It's really nice.
It's the elephant theme.
And they know about my space background. I'm an aerospace guy, so they got me a nice book reading for the plane ride back. And then, of course, some swag from Tufts, of course.
Hope it fits.
Don't worry, my wife will be wearing it. It's okay. It doesn't fit me. It'll fit someone. She wears all my gear. Well, thank you so much. I really appreciate it.
Thank you very much.
My pleasure. Yeah. I think you have a class in here, right?
We do. So before we go, I do want to actually acknowledge we have a special guest in the audience who's related to a member of the Jumbo family. Welcome President Barabino from Olin College. We have a history with Dr. Barabino. She actually was one of the first people who I interviewed with when I was looking for a job out of grad school. And I'm still here. So thank you for the encouragement at the time. And also I want to thank President Monaco, as someone who knows how difficult it is to get in the president's calendar. I really appreciate your presence here, but also not just being here today, but your incredible leadership in DEIJ, and for standing up and declaring Tufts an anti-racist institution 2 years ago, making Juneteenth a university holiday. It's been just inspiring to watch you in your leadership role, supporting this effort and leading us up front. So thank you very much, Tony, for all that you've done in this place. And with that, thank you all for coming, and have a great weekend if I don't see you.